Okay, we're in section 4.4, series parallel circuits. These are the third type of circuit that we're looking at in chapter 4. Series parallel connections are another way of connecting electronic components. A series parallel circuit is a combination of series and parallel components. The series and parallel components must be identified for accurate analysis of the circuit. To distinguish series versus parallel components, reduce each section to a single resistor, series or parallel. If it cannot be reduced, it is a complex circuit. So here we have a series parallel circuit, and you'll notice we have R1 and R2 are in series, and R3 and R4 are in parallel. So what we're going to do is, this is our goal here, to simplify to a power supply and one resistor. So our goal is to simplify this circuit to a single power supply and a single resistor. Well, we know what our power supply here. We've got 10 volts here, and we'll put the little ground right here. But we want to know what is the combined resistance that we have over here. So what we will do is we'll add up these two together, and we'll look and see what 250 and 750. So these two, if we could combine those into one single component of, let's see, 1000, 1K. And then we want to combine these into a single component as well. So let's get our calculator, and that will aid us in calculating the parallel value. So here we have 800 ohms. So let's say we'll put in 800, and we'll do the 1 over function, and then we will go plus 500. Again, we'll do the 1 over function, and then equals, and we have 3.25. And again, we'll do the 1 over function, and so our total resistance there will be 307 ohms. So we could X out that and that, put in one value here of 307 ohms. And so our total resistance here we could say 1,307 ohms. So that would be our simplified values for this particular circuit. And what we did is we simplified this to a power supply and one resistance. Here is another one. Let's go ahead and simplify it. We'll note that we have these two components are in series, but these three are in parallel. So again, let's get our calculator, and let's calculate the parallel resistance. So let's start out with 400 ohms. So we'll go 400, and we'll do the 1 over function, and we'll add that to 500 and the 1 over function, and we'll add that finally to 2K, 2000, and the 1 over function, and then this will equal 5 exponent minus 3. So if we do the 1 over function here, we'll find the total resistance is, it looks like 200 ohms in the parallel portion of this circuit. So we could, if we were to eliminate this out of the circuit, we could replace it with a 200 ohm component. And so if we were to redraw this circuit, we have our 50 volts, and we want to reduce this to a single component. Well, now we have three components that are in series, or we have 200, 400, 500 ohms. And so we have reduced this series parallel circuit to a single power supply and one component. And then we have this is also in this section, and we don't have any component values in here, but I do want to talk about this, and I've subtitled this, "What is this?" And so we can look at this circuit. This is well, let's talk about it. We can look at this. Notice we have R1 and R2. These are in parallel. We could combine these two, but R1, R2, those represent a series circuit, and down here R9, R10, we could combine those into an R9, R10. That would be, we could do a parallel value here. But when we get over here, things get a little more complicated, and it isn't so clear as to what is in parallel and what is not. We need to take a look at this. We can R3 and R7, they seem to be in series, but then R6 is connected in here in a funny way. R6 is not in series with this, and it's not in parallel either. I think we could go over here. I think we could do these two components are connected to the same point. We could put these two R4, R5 into a parallel relationship. Let's jump to the next slide. I think we've got another picture of this that has combined those two lower components. The two are upper, and then R4 and R5. Now, since these two effectively, once we add them and do the parallel conversion here, they could summarize to something like this, and we could do a series parallel circuit and combine those components, and that would make perfect sense. And over here we could combine R4 and R5, but still R6 kind of falls out of it's not in series and it's not in parallel. And what we call this is what we refer to as a complex circuit. It is neither series nor is it parallel. We will well, we won't look at this in this particular course. If you take advanced courses, we will go in and analyze what a circuit such as this. This is typically, this particular circuit is referred to as a Wheatstone bridge. But we will not be doing calculation for this. But you do need to be able to identify what is a complex circuit. We will deal with series, we'll deal with parallel, we'll deal with series parallel. We will not deal, or we will not do calculations for the complex circuits. Okay, so in this particular, this was a rather short lesson. We looked at the series parallel circuits, and we played with simplifying them. Now, when you go into your text, there's quite a few examples addressing this, and you will need to work through these, and there's quite a few problems to be solved in this section, so it went quite quickly as a presentation, but there's I want you to get familiar with doing these kind of calculations, and so it's one thing to see someone else do it, it's another thing to do it yourself. So make sure that you are fluent in doing the kind of thing we did in this circuit in calculating series to series parallel circuits and simplifying them to a single power supply and a single resistor.